Hello, my name is Gary Henderson. I'm the Director of R&D for Gravitational Systems Engineering, a United States-based company in Virginia. And today I'm going to start a series of videos to explain our technology by explaining some of the underpinnings of it. Today I'm going to talk about DSE, that is to say, Dynamic State Energy Systems. DSE is an abstraction, an energy abstraction that has its roots in Einstein's equation E equals mc squared, and we'll talk about that a little bit more later. A DSE, which some that we're familiar with today, are as opposed to fuel-based systems. For example, the burning of fossil fuels or the chain reaction induced in nuclear fuels involves some conversion of the original material into a new form. A DSE involves generating energy not from the conversion of matter, but from harvesting it from the change or the dynamic state of matter. That's why it's called DSEs. The DSEs you're familiar with are solar, wind, hydro, and to some extent geothermal. But if you think about wind, the wind is still there. What we do is with a windmill, we harvest some momentum from the wind. With solar, it's a little bit more complicated, but we're looking at a source of energy wherein photons are coming down from the sun, and the movement of those photons and their energetic nature is used in order to generate energy. With hydro, once again, the movement of fluid. Now, I say it ties all back to Einstein's original equation, that is to say E equals mc squared or E equals mcc, because the fact is that when we think in terms of energy generation, if we think about the fuel model, we're basically thinking about the M side of it, and that is to say the mass. Right, the mass that we apply some velocity, that is to say combustion or a chain reaction to, in order to generate energy. So that fits in. DSEs, on the other hand, derive their energy from the C side of it. That is to say, the MC. The M side is for fuel, and the C side is for dynamic states. Now, when we think in terms of that, that particular side of the equation, we realize that first of all, our original sources of energy were DSEs. Wind is probably the oldest energy source we know of. It was an energy source before we even knew it was. But now we're finding that if we examine that equation and that understanding, a couple of things come out. First of all, when you think about that E equals mc squared, the c squared, we're talking about the limits. The speed of light, the c is the speed of light. But the fact is that any velocity times mass is going to equal energy, even if it's only 1 mile per hour. It will generate less energy, but the point is it will generate energy. Now, at Gravitational Systems Engineering, we have taken that particular equation and focusing on the c side of it, and that is to say the velocity or the dynamic state, we found a number of ways that we can harvest energy from the environment. And the key point is that this energy, just like solar and wind, is non-polluting, absolutely green energy, and yet it has certain advantages. The first advantage is the energy that we're able to harvest through what we call momentum inertia, and I'll explain that in a second, is much denser than could be supplied by solar. For example, we can take a stretch of roadway and fit it with our DSE devices, a device known as the traffic tap, and we can generate as much energy as an array of solar panels that would stretch, for many, many square miles. And I'm talking about state-of-the-art solar panels. We're talking about a technology that can be applied to the roadways, that can generate the kind of power that we need, and it has a very key advantage, this traffic-based system, a very key advantage over solar and wind, in that it is, instead of being dependent upon the state of energy or the state of the environment, it's dependent upon activity. Now, this is basically how it works. When we get in a vehicle and drive it along, we know that we're consuming energy in terms of gasoline or whatever method you're using, electric, the like. You're consuming energy, but that energy is not being destroyed. Energy can't be destroyed. It's the same as matter. It cannot be created or destroyed. All it can be is basically moved around or converted to a new form. When you're driving in a vehicle and you know that you're expending power every time you go to the gas station, and we're aware of the potential energy that's in front of it. For example, if you're driving in that vehicle and you hit a tree or you hit an animal, God forbid, the tremendous energy is going to be diffused into that structure, right? And you know, we can go into the whole inertia of it and the like. But what we don't realize is that just as energy is going before, that is to say potential energy in case it hits something, there's a constant flow of energy that's coming out of it. Now just imagine that if instead of hitting something with it, you run over something, an animal, right? Or a tree stump or whatever. What happens is energy is diffused into that animal, that is to say, vertically into the roadway. Now that may seem incredible, and yet we realize that all the time. You obviously don't want someone to run over your foot because you know that there's going to be energy. And the fact is that roadway maintenance and roadway design has been aware of this fact for many, many years. That is to say, without the movement of traffic over the roadways, they would last a lot longer. For example, there have been some cases where bridges have not been utilized or been lightly utilized. Realize that a bridge will last twice as long if it only encounters light traffic or no traffic at all. In the same environmental conditions, the same material, and the same structure. Why? Because when those cars or vehicles are going over that bridge, they are expending a tremendous amount of energy into the surface of the roadway. Now, some people think when you say, okay, we're going to collect energy or find some way to take energy from moving vehicles, there must be some penalty associated with the vehicles. But this is absolutely not true, and this is one of the basic misconceptions that people have of our technology. Just to give you for example, a few years ago in Israel, based upon our designs, they embedded piezoelectric into the roadways and ran cars over them. It was completely transparent to the cars. They couldn't see it. Piezoelectric is a kind of ceramic material that if you squeeze it, it generates a little charge of electricity. Now, the performance of it wasn't good and the costs were too high, but it proves the point. It's proof of concept, and that is to say that a vehicle running over a roadway that has some ability to harvest that energy is generating energy into the roadway. Okay. Now, methods of capturing that energy are going to vary, and the best state-of-the-art that we've developed at GSE are methods that involve some sort of conversion to mechanical activity. And that's far from perfect, and yet it has certain advantages. In a later video, when we talk about exponential decay functions and being able to implement those using GSE devices, I think you'll see how valuable that can be. But for now, let's just realize that, first of all, and because I don't have much time here, DSE, the DSE concept, and that is to say dynamic state energy systems, is an abstraction. That is to say, if you looked at energy, you would say or energy sources, say there's two sources. There's fuel based, and that is to say where you've got some energy that's been captured and concentrated in fuel over long, long times, and that we bring and that we convert. That's working on the mass side of E equals mc squared, and you've got DSEs that work on the C side of E equals mc squared. And that is to say solar, hydro, wind, and what we're talking about here, momentum inertia power. Now, let me just throw the sales pitch in for momentum inertia power. That is hard for me to say. Momentum inertial power has a distinct advantage, or a couple of distinct advantages over other DSEs. Just like solar and wind and hydro, these are clean. No pollutants that are involved, and as I pointed out, there's no impact, or there doesn't have to be any impact on the passing traffic. DSEs, however, are in most cases dependent upon nature. For example, the wind blows when it wants to, the sun shines when it wants to. With momentum inertia power, DSEs, the energy is generated by demand. For example, how many times have you been on a roadway late at night and saw that the roadway was lit for miles and miles? This is wasted energy. And why is that? Because that's the way it's always been done, and because with grid-based power, power is relatively cheap at night because there's not demand for it. The result is they do it. And yet, if there's an earthquake or some other problem that cuts the connection to the grid, all of a sudden, when you need the lights the most, they're not available. If in fact we were using momentum inertia power, when you've got all that traffic on the road, whenever you've got traffic on the road, you're going to have a lot of power. And now let me just point out this. Not only are you going to have a lot of power that's demand based, but it's local power, and we're providing power sources today in the form of compressed air and fluid movement. If you go to our website, which is gravitationalsystems.com, and look at some of our applications, you'll see that dense power, because we're talking about every car is generating 15 watts of energy, dissipating 15 watts of energy into the roadway, and every truck up to 200 watts per quarter turn of the wheel. So that means as it's going along, it's generating that power, it's generating a wave. As a matter of fact, engineers, the people that deal with earthquakes and the like, have long studied what are known as P waves, or pressure waves, which are waves of energy that propagate through solid earth with no necessary movement. The point is that with momentum inertia power, we can provide dense energy for some amazing applications, including things like drought reduction, environmental remediation such as air pollution, aquifer cleanup, big things that are just totally impractical to do without this kind of dense power. Now, our systems, we have retail systems, surface mounted and embedded systems that are available for sale, and we've got considerable funding to provide demonstration projects. So please go to our website, check it out. If you want to send me an email, my email address is Gary.Henderson, and Gary is spelled Gare, .Henderson, Henderson, at gravitationalsystems.org. And as I said, we're going to be doing a whole series of these videos, so look for them. Just do a search for Gravitational Systems Engineering, or search for me. Okay, I do appreciate your time. I hope that I haven't created more questions than I've answered, but DSEs, that's the future. Thanks.